This is the video for the solutions for the mock for correlation regression with Spearman's correlation coefficient. So number one, the marks obtained by A candidates in physics and chemistry tests are given below. Write down the product moment correlation coefficient R. That means the Pearson's correlation coefficient. So remember that whenever you want the whenever you need the Pearson's R value, you do need to configure your calculator to do so. If you haven't reset your calculator afterwards, it'll still be set that way. But if you've reset your calculator recently, then you go into mode and you go down here to the second page, and there's this thing that says stat diagnostics. You turn it on. Enter. You get out using second quit, and then now we can go ahead and put our data in here, and they've kindly told us that the first row is X and the second row is Y, but the first row is always X and the second row is always Y in these math studies or applications and interpretations problems. So first you go into stat, edit, and then you have L1 and L2, and we're just going to put in our X and Y values in columns. So we have 6, 8, 10, 11, 10, 5, 4, 10, 5, 4, 12. And then you go to the next column and you put in the Y values, 8, 11, 14, 13, 11, 7, 5, 15. Now what does this mean? It means the person who scored a 12 in physics scores a 15 in chemistry. Okay. So after you get all the data in there, let's just make sure it's right. 10, 14, 11, 13, 10, 11, 5, 7, 4, 5, 12, 15. Looks good. Then we want the R value, so we just press stat calc and we go down to number 4, which is linreg AX plus B. You should choose this one and not linreg A plus BX because we're used to seeing the MX plus C form. X list should be L1, Y list should be L2, frequency list should be blank. Go down to calculate. And it tells us, first of all, that the equation of the line would be Y equals AX plus B, and A is 1.15. Actually, it's 1.1544. But we only want 3 significant figures, so we stop at 1.15. X plus B value, which is 0.976. So 0.976. And we put it in B because actually they're asking for that information for B. Okay, and our R value, they're asking for it in A. So the R value is 0.965. Okay, and let's say that they asked you to comment on your R value. Now, I'm just going to review really quick that the 4 levels of correlation are strong, moderate, weak, and very weak. And so very weak would be between 0 and 0.25. Weak would be between 0.25 and 0.5. Moderate would be between 0.5 and 0.75. And strong would be between 0.75 and 1. Okay? And then also remember that when you do comment on the R value, you will also say whether it's negative or positive. So in this particular case, if they asked you to comment on the R value, which they didn't, you would say positive strong, right? Because 0.965 is between 0.75 and 1, right? Okay. So we've already done A and B. let's look at C. A ninth candidate obtained a score of 7 in the physics test, but was absent for the chemistry test. Use your answer to B to estimate the score he would have obtained on the chemistry test. Okay, sometimes when they ask you for these kind of estimates, they ask you to use a graph done on grid paper. In this particular case, they're asking us to use the equation. So we're going to take the equation in B, and we're going to substitute in the 7, which he got in physics. Remember that X is the physics score, so we're just going to put 7 in there, and that'll give us the chemistry score, which is Y. So 1.15 times 7 plus 0.976. So I'm going to do that by hand, and then I'm also going to show you how to do that with the calculator kind of automatically. So 1.15 times 7 plus 0.976 gives me 9.026. Now, if we're going to estimate the chemistry scores appear to be whole numbers, so we would round that to 9 because 9 is closest, right? There's another way you could do this, is you could, when you do the stat calculate in reg, I don't know if you noticed it, but there is an additional field that we haven't used, which is store reg equation. Store reg equation can put it right into the y equals screen. So we can go here and then we press vars. We go into y vars and then we press function and we put like y1. And that'll put y1 there. And then when we calculate the equation, 1.15x plus 0.976, if we go into the y equals screen, it's already plugged in there. So now that we have it in there, if we go into second table, for example, we can see all the values for different values of x here. And so, for example, they said if he got a 7 in physics, what would be his chemistry score? And look, if we look at the table in the row with x equals 7, we can see that the y value is 9.06, which is a little bit different than what we got here because we rounded our slope and our y-intercept to 3 significant figures. So ours is a little bit different than theirs, whereas like they kept a whole bunch of digits. That's another advantage of using reg equation because it keeps like all the digits, right? Okay, so basically our estimate would be 9. Then we're going to go to D. Give a reason why it is valid to use this regression line to estimate the score on the chemistry test. Okay, here you're going to look at two things. One thing is you're going to say, okay, I can use this equation to estimate other possible values because, one, the R value is strong. Okay, so it's strong correlation. So that's one reason. The other reason is, do you notice that the value 7, the physics exam score that they're asking us to predict the chemistry exam for, if you look at the values of the physics exams that we sampled, 7 is within this interval of data, right? The smallest physics score we got was 4. The largest was 12. 7 is within that data. So imagine if you have, a bunch of data, and, it's basically the data between 4 and 12. And then you said, okay, well, what happens if you're looking at this 7? The 7 is like right within your data 4 through 12. So it's pretty reliable to be able to estimate that the relationship between the physics and chemistry exams for 7 follow the relationship that you've already seen between 4 and 12. Now, if they asked you to figure out what the chemistry exam score is for a physics score of 15, do you see how that would be a little bit more of a risk? Because you see how 15 is not within your yellow data cloud. So how do you really know that the yellow data cloud doesn't like curve up all of a sudden or whatever? You don't know, right? So since you don't know, it's not really reliable if the input number that they're asking you to predict the output number for, if it's like kind of outside of the data interval that you have, then it's kind of risky. So the other reason why you can predict the chemistry test is because the 7 physics score is within the data interval, which in this particular case is between 4 and 12, right? All right. So those are the two reasons that you should give. On the other hand, if they ask you why it would be unreliable, two possible reasons would be your R value is weak, and another possible reason is that the data input value is outside of the interval of data that you have. So E, it says to complete the ranking of the marks obtained by the 8 candidates in physics and chemistry tests below. Now what they're asking for here is they're asking you to say which marks are the highest and which marks are the lowest. You can see they've already done part of it for us. So like for example 12 is the highest physics mark, the second highest physics mark is 11, and they've already labeled 12 as rank 1 and 11 as rank 2. So 10 would be rank 3 and 4, but they're tied for a third. So actually in this case, since they should occupy third place and fourth place, we take the average of the two and we're going to put 3.5 for each one. So we'll put 3.5 for both of the 10s. Then 8 would be fifth place because third and fourth place were used by both of the 10s. And then sixth place would be the 6th. And then seventh place would be the 5. And then eighth place would be the 4. And then for the chemistry test, the best score is 15, the second best score is 14, and the third best score is 13. There's no 14, there's no 12. The 11 would be the fourth best score. Oh, there's two 11s, so actually fourth and fifth place would be 11. So that means that I need to mark the 11s with 4.5 and 4.5. And then, so 11 was fourth and fifth place, so now I'm looking for sixth place. Sixth place would be 8. Seventh place would be 7. And eighth place would be 5. Okay, so now I've put, ranks for every single one of the physics and chemistry scores. Now it asks me to find the value of the Spearman's rank correlation coefficient R subscript S. And the way you do that is you put this data here into L1 and L2 and you run linreg again. This time you're not interested in the equation of the regression line. Now what you're interested in is, oh, I'm sorry, I need to go to stat edit, not into Y1. So I'm going to clear these out first. What you're interested in now is just the R value. So we'll start from the left and go to the right. We need to go the same order for both to make sure that, you know, the 6 chemistry is together with the 6 physics. The 5 physics is together with the 4.5 chemistry, because these are, each one of these is like a person, and we need to see like how the chemistry and the physics test for each person relates to the other. 2, 3.5, 7, 8, 1, 7, 8, 1. And then now I do the chemistry scores, which would be the Y. So it would be 6, 4.5, 2, 3, 4.5, 7, 8, and 1. And then now I'm going to do stat calc linreg, option 4. L1, L2 blank. This one should be blank. And then we go down to calculate. And we don't care about A and B in the case of Spearmans. All we're interested in is the R value, and the R value is 0.946. And now we comment it similarly with the way we commented before. We look at the value 0.946, and we look at this table. We can see the 0.946 is clearly strong. So we'll say it's a strong correlation. And we also need to say if it's positive or negative. This one's, of course, is positive. Okay. Okay, last of all, it says that the chemistry test score of 8 is regraded and changed to a 10. Explain why R subscript S would not change. So if we look at the chemistry score of 8, it's this one here. Let's say that this changed to 10. So if 8 changed to 10, it would still be smaller than the 11s, and it would still be bigger than the 7, right? So if 8 changes to 10, the rank that it has, which is the 6th rank, would not change because it's still between the 4.5s here and the 7 here, because it's still between 11 and 7. So that's what we could say. We could say the rank of the chemistry score of 8 would still be 6 because still between 7 and 11. So rank doesn't change, so R subscript S also no change. Okay, you don't have to write that much, but you'd write something like that. Okay, let's go to number 2. The following table gives the amount of fuel in a car's fuel tank and the number of kilometers traveled after filling the tank. Okay, so it's kind of like the capacity of a gas tank. So we're going to graph these points, and usually they're going to give you the x coordinates first and the y coordinates second. And they've already graphed some of these points, so we can actually check which ones just to make sure that it's x on top and y on bottom. For example, there's one here which is about 275,30. So that would be this one here, right? So they already graphed that one here, and yeah, it's the x coordinate is the distance, right? And the y coordinate is the liters. So that's the way we're going to graph these points, okay? So let's start with 0, 55, which is the first point. So 0 is the x, and 55 is the y. And oh, they've already graphed that one, okay? What about 220, 43? 220, 220 is here. 43 is, this would be 50 right there, right? So 43 would, yeah, so it would be that one here. So they already graphed that one too. What about 276, 30? So 276, 30 is the one that we just saw. So it would be that one. 500, 24. That 524 would be about there, right? But slightly below that line because that line would be 25. So I'm going to put a little x there. And then 680, 10. Let's see, 680 would be right there, close to 700. 10 would be right there. So let's mark that with an X. And then finally 850, 6. 850, 6. So 850, 6 would be 850 is there, and 6 would be slightly above the line there. So it would be about like that. That's 850, 6. And so there's one extra one here. We don't know what that is yet, but let's move on and maybe they'll explain it. So it says the mean distance traveled is 421 kilometers. That's x bar, which is the notation that usually we use to figure out, to show the mean x value. And the mean amount of fuel in the tank is 28 liters, y bar. This point is plotted on the scatter diagram. Remember that sometimes in the problem set they asked you to figure that out, and the way you figured it out was you would go to stat edit. You go to stat edit and then you would put your data in to L1 and L2, and then you would do stat calc 2 var stats. And if you do 2 var stats and you put L1 and L2 for X and Y list and your frequency list blank, it will give you the X bar value, and if you go down a little bit, it gives you the Y bar value. So the calculator does give you this information, but in this particular problem, they actually give it to you. And then it says this point is already plotted on the scatter diagram. It's right there, right? 421, 28, that looks about right. And then it says to sketch the line of best fit. Okay, so one thing that you need to remember about sketching the line of best fit is that you always need to go through the mean point. So what they're going to be checking here is that you are going to draw a line that goes through the mean point, and use a ruler when you do this. I just can't use a ruler here because I can't use a ruler on this touch screen. But basically you're going to draw a straight line through these points, and the objective is to kind of put it in the general direction of the points and to have about the same number of points on top as are on the bottom. So it would look kind of like that if I could just draw it straighter. So it looks kind of like that, right? And the important thing is that I kind of have the same number of points above and below it, and I do go through the mean point. Okay, those are the two objectives. They're going to give you 1 point for going through the mean point, and the other point they're going to give you for basically following the direction of the other data points. So I did that. Now I'm going to answer a question. They say a car traveled 350 kilometers. Use your line of best fit to estimate the amount of fuel left in the tank. So 350 kilometers, that corresponds to this distance here. And that says use the line of best fit to estimate the amount of fuel left in the tank. Well, what that means is we're going to draw a vertical line from that point of 350 until we hit the blue line, and then we go horizontally until we hit the vertical axis. And it looks like we're at about maybe 32 or so. So we'd say maybe like 32 liters. And if you're close to what they recommend, it's like the important thing is that it corresponds to your graph. Okay? So, and that's it for this mock exam.